Okay, good evening, everyone. So happy to have everyone here. And this is the 9th Kubernetes user group meetup. And today we have one exciting use case to discuss from some of the experts from AWS. But before that, I have a couple of announcements as well. So yeah, but I'm really happy to have a full house today. And yeah, hope everyone have a good time today. First of all, I would like to thank Amazon for providing such an ambient value for a venue for us, which can accommodate such big crowd. But I think now it's our responsibility to keep it clean. So we humbly request you not to litter here, and please take care of your belongings and take your belongings back with you when you leave this venue. We had an attendee last meetup. She forgot her umbrella here, and she made us all crazy. So please take care of your belongings. Please do not litter, and let's keep the area hygiene. Thank you so much. I will go through the introduction slides really quickly, and without wasting much time, I'll hand over my mic to the AWS team. Yep, I would like to first thank all the sponsors. We have today's event sponsor is AWS. Apart from that, we do have some giveaways from Core Cloud and Cloud CNCF as well. One announcement, on 7th of May, there is a Cloud Native conference going to take place in Toronto, just beside the CN Tower. And the tickets are, we have a production issue. The tickets are live. So for all the community members and whoever is attending today, we have a special discount. You can scan the QR code. You can use that 25% discount. Apart from that, we have some special student discount or women in tech discount as well. So do not miss this event. It's a day-long event with jam-packed cloud native discussions and all some folks from CNCF as well. Next up, currently up until 30th April, Linux Foundation is also having their promotion on trainings and certification. Some of the popular CNCF certifications are CKA, CKD, CKS, and so on. You can claim 40% discount. You can use the promo code right on your screen. You can scan the QR codes as well. And yeah, without me taking much of your time, today we have a really good production grade discussion on EKS from experts, one of our dear friend Karl, who is application modernization specialist at AWS, and Mathieu, who is solutions architect at AWS. So yeah, hope you guys have enough battery on your laptops, and it's a hands-on the workshop. So yeah, probably I get a seat now, and I should learn to it. Thank you so much, and hope you enjoy.
Lovely to see everyone here again. I've been with you all, but anyway, having said that, we have agenda for you. We walk you through our managed Kubernetes 10-minute kind of presentation format, and we'll use the rest of the time to actually take you into the workshop-based experience. In terms of who the two of us are, I'll let Matt introduce himself, but just by way of how we go through and speak to our customers, think of us as an extension of the Amazon EKS product engineering team. We work alongside our customers to understand what works for them, what doesn't, take that as feedback, enhance the roadmap, also help with optimizations in production environments, so give architectural advice, as well as help with architecture design and so on. So super excited to be here today. Feel free to ask as many questions as you can, but that will be much more interactive and for you at the end of the day. And one final request, we have a feedback survey that we'll share a link to. Please fill that in and share your views as openly as possible, because at Amazon, we're extremely customer obsessed. Today, you all are our customers. So make sure you provide that feedback, because it helps us improve the way we deliver our content and the way we engage and run our workshops. So with that, I'll hand over to Matt to introduce himself.
Sure. So thank you, Karl. So I'm Matt Bruneau. I'm a container specialist at SAFe. working at AWS, really focusing on the container services. So tonight we'll speak mostly about Elastic Kubernetes Service, or EKS as we call it, but I also cover other services like ECS and a couple others. So if you're interested in speaking about that, I can definitely do that. Is there somebody that can confirm that the Zoom link is receiving the screen share and the sound? Perfect. Thank you very much. All right, so this is a Kubernetes user group, so I probably will not learn you much about Kubernetes tonight. So I'll briefly really cover, the Kubernetes architecture. You all know about this. There's two main, division categories, call them the way you want. There's what we call the control plane, which is, your API server, your etcd clusters, and then you attach what we commonly refer to as the dev planes, or, in Kubernetes world, this is your worker nodes. That's where your kubelet, your pods will be running. This is really, the architecture, a very high level of any Kubernetes clusters running out there. So, if we look at how Amazon EKS bring this to the table for you and what actually it brings to this. So the goal of EKS is to help our customers, AWS customers, to reduce all the cost of operation when they are expanding their business with Kubernetes. It does provide a fully managed control plane for people running inside of AWS, as well as a couple options outside of AWS. We do support the last 4 versions of Kubernetes. So with what we call the standard support for about 14 months. And we recently launched something we call extended support, which adds an additional 12 months of support. So total of 26 months with basically by just paying a small fee per hour for the actual control plane that you're running inside of AWS. So it is a solution that is oh, okay. My bad. I don't see them here.
Yeah.
It'll be very hard to move. Yeah, I mean, there's not much in the top. I think that would be good. All right. Right. So Kubernetes EKS is what we call Kubernetes compliant. So conformant. So that means 3 things. So one, AWS provides timely update to the new version when it comes in. Sorry. The API is consistent. So if you're running EKS 129, 128, and you compare that to any of their 128 clusters, you'll get the same kind of response. So it should not break anything that supports the standard. And you don't have to trust yourself. The third thing is you can run the tool to validate that it's actually conformant. So you can definitely do that. So in practice, how does that work? And I lost my mouse. All right, perfect. So the actual control plane that we run for each cluster inside of Kubernetes is exactly the same as if you were building it yourself. So we're using the auto-scaling groups with the networking, the network load balancers. We're running 3 instances for your etcd clusters, as well as 2 instances of the API servers. It was built to be to survive any kind of single AZ, availability zones failure that could happen. So to minimize really the disruption that could happen to you while you're using an EKS cluster. It's backed by 99.95% SLA support, 24 hours a day, 365 years per year. We also do automatic resizing of your control plane. So if if you start with a couple of nodes, perfectly fine. If you grow to couple hundred nodes, at some point the etcd cluster and there's a little bit more pressure on your control plane. So we do automatically resize this for you. You don't have to worry about this. And that's really what there is to EKS, is everything you see on the screen, you don't have to worry about because AWS is taking care of it for you. So what you really have to think is what's happening in the next slides. So the control plane is actually running on an AWS account that is managed by the EKS team. You don't even see those nodes or anything of this in your own AWS accounts. The only thing that you can see are what we call the Elastic Network Interface, which are basically network interface to have an IP address to be reachable inside of your virtual private, your VPC, basically, which is your network inside of AWS. From there, you can attach almost any kind of nodes. There's different solution. We'll see that in a second. So the two main way to attach nodes to an EKS clusters, you can, if you're, I suppose most people are familiar with EC2 instance. There are just virtual machine. You launch them in your VPC, you attach them to the network interface, and at that point, they'll be able to run any pods that you launch in this. We also have a service called AWS Fargate. It's kind of a fully managed container environment to run the specific pods. Those are kind of micro VM that you can launch. You can size them based on CPU and memory that you want to use. When the pod terminates, the actual Fargate host that was running that pods, just go away. It's reclaimed, it's destroyed, those kind of things. So if you're interested in isolation, that may be a good solution for you. If we look at the EC2 option, you can, there's two main ways. The most popular one is to use the managed node groups, as we call them. Basically, AWS takes care of all the components that needs to be spin up, created for you to attach nodes to your clusters. It's very easy to start. Takes only a couple of minutes, and that's what we will be using in the labs. If you need a little bit more flexibility, something not covered into the managed node groups, you can still build your own. We call this the self-managed node groups option, but basically, not a ton of people needs to go there. A lot of flexibility was added to the managed node groups in the last few months. You can use almost any of the instance available inside of AWS. That could be GPU instance, specific ARM instance, the Graviton chips that we have. All of this is supported as well. Spot instance, saving plans, all of this is covered. We have a couple options to run EKS outside of AWS as well. So we have an option called EKS Anywhere. So if you're interested and you have your own on-prem hardware, for example, we also have AWS Outposts, which are basically hardware that we can ship to you in your own data centers, most probably, where you can run EKS as well. And there's a couple more niche options like the local zones or the AWS Wavelength. Quick slides on Fargate. So basically, like I said, it's a micro VM. The only thing, just like the control plane, this run in a VPC that's managed, an account that's managed by the Fargate team. You won't actually see it in your EC2 console. The only thing that you can see is the network interface, so it can communicate back to your control plane, your EKS control plane. So this is a very nice way to run your pod in full isolation if you need to. Couple of things that is a little bit different in AWS than other places. You can the recommended way to run your cluster is to have a private only endpoints, so it's not exposed on the internet. So it's only available inside your own private network, your VPC. Most people are probably familiar with the CNI plugin that Kubernetes supports. AWS has its own VPC CNI, we call it. So the Amazon VPC CNI plugin. By default, every pod gets its own IP address inside of your VPC. They will, if you have multiple containers inside the same pod, they will all share the same IP address. And the goal of this is there's nothing really happening. So people that are familiar with over the networks, for example, it's inside the VPC, it's totally transparent. All the IP address can talk directly to each other. There's no NAT really happening. So small diagram here. We're using secondaries IPs of your EC2 instance. So if you want to use that, that's definitely a good way to do this. We do support, we are Kubernetes conformant. So if you prefer to use another CNI plugin, there's definitely people doing this. There's a very common one and a few niche ones that we also support. Right, if some people do have specific needs for storage options, so inside of AWS, we have a couple of options that are available. We do, we support all the way from directly attaching EBS volume to your PV or PVC, all the way to enterprise FSX style of storage option that are available inside of AWS. If you have specific needs for this, feel free to contact your AWS preferred person, and they'll be able to guide you if you have a need for this. A question we often get asked is, how do I start using EKS inside of AWS? Actually, that may be a good question here. Who's familiar with AWS? About 10% of the room. So that's probably a good question for everybody else. So we have a project called the EKS Blueprints. Basically, the blueprints have two flavors. One of them is using Terraform. The other one is using what we call the AWS CDK, the Cloud Development Kit, which is a little bit closer to code. So those projects allows you to, are basically a way to kickstart you in creating a cluster inside of AWS. It will help you create the VPCs, the NAT gateways, and basically all the way to the control plane and attaching specific nodes to your clusters. So that may be a good tool to look at, especially if you're familiar with Terraform, for example, or CDK. We also have another tool called EKS CTL. It works a little bit like kubectl. You can pass in a YAML file, for example. The difference is you'll pass in a cluster configuration, and EKS CTL will be able to spin up the cluster by using the cluster config that you pass to it. There's other, there's CloudFormation, there's directly using Terraform. Those are all good ways of doing this as well. Is there any question before we jump into the lab section of it? I see one question. Sure.
First one is around the target.
Yes.
So through the documentation, we know that there are different modes for typical target. You have the ECS and
Yes.
Kubernetes. What is actually different in terms of underlying infrastructure?
It's the same underlying infrastructure.
Okay, so let's say the upper layer, the upper abstract. You were talking about the micro VM.
Right.
Is it like Flickr?
Firecracker.
Yes, sorry.
Yeah, so yes and no. So there was a question about Fargate usage and difference between ECS and EKS. I don't want to go too deep here. We want to focus on EKS a little bit more. So ECS has a couple more features to use on Fargate. Is it me? No, good. There's a couple more features that's only available on ECS. But it's the same underlying services for both of them. That being said, for example, there's Windows. On ECS, you can run Windows containers. Those ones don't use Firecracker because Firecracker does not support Windows. So it's a mixed fleet underneath.
When you say RJ, that's the ECS version.
There's feature that's only available on ECS, but it's the same underlying service. Right?
One is running ECS, the other is just
Yes.
several Kubernetes somewhere.
Yeah. All right. And I'm happy to discuss this more if you want, but for now. Is there any other question? No. The issue will be with holding the mic. There's no arm. Just okay. Can you still hear me? Yeah. Oh. Sorry. Is it better like this? Okay. All right. So for people with a laptop, if you have a way to scan and send you a URL, you can use a QR code. Otherwise, you can type the URL here. I will have to switch the screen share a little bit. So what we did is we provisioned accounts. So we have 89 accounts. Hopefully we cover everybody that's interested to join in. Where you have already a EKS cluster with 3 nodes, and we'll be playing a little bit with it through what we call the EKS workshop. I'll let a couple moments for people to grab the URL, the photos. See a lot of people went through this. Sure. So that will be 129. Is this good version? Okay, yeah. Yes, the Wi-Fi password is on the board at the back or at the front over there. That works. The password is broken wires with capital letters and 2 @ symbol. And yes, 2019 is, yeah. Let me just change the screen share. This. Right. Was everybody able to grab the URL? Yes? Great. Perfect. So if you grab the URL, you will end up on this page. I'm sorry, on this page. After you did the one-time password login, I'm sorry, I'm sure.
Might be more efficient to like post it in the Meetup page, so that people can just copy that.
I don't, if somebody has access to do that, that'll be wonderful. I don't have I'm not logged in to the Meetup page on this computer. I can paste it in the Zoom chat if somebody.
You can grab this, if you can just look again.
All right. So the lab will be up and running. Your lab environment will be up and running for up to tomorrow night. So if you plan to work on the workshop tomorrow, that's fine as well. All right. So when you get through, you'll basically land on this page. First thing you probably want to do is click on open the AWS console. So there's a lot of people not too familiar with AWS, so I'll be walking through those steps with you. We will be using the region that we call US East 2 for the lab. So if you were logged in into the console on different things, just make sure the cookies then it brought you back to another region. So if you have the console open, the next step you want to click is get started. And all the way at the bottom, there's the link to the actual workshop page. So it's the last part, it's in the URL, right? The last part of the URL. If you, depending of Yeah, it's the last, I don't know, 12 digits or so. Or, yeah. It's basically this part. Just want to make sure everybody's able to log in. Everyone's good with the URL? Okay. So let me just, before we jump into, on the top, there's actually multiple section, right? So we will be running the fundamental section, just to get accustomed to the workshop environment. And I was planning to run the auto scaling section of Carpenter, which is a kind of a replacement for cluster autoscaler built by AWS. If you're very familiar with Kubernetes, there's chances you may be able to move faster. That's perfectly fine. I can answer almost any question, no problem over there. Otherwise, just follow with me. Up to you. Yeah. So the section at the top, there's also modules on the left. Basically, each time you see a title with the labs is a specific section. You can run through different section. That's basically what we are telling you in the first page. The other thing we will be using is something we call Cloud9, which is kind of an IDE in the cloud. So if you go to the Cloud9 consoles, you should have an environment called EKS Workshop. So you will want to open this. Should take a couple of seconds for your instance to come back up. Right. You actually mine. I did open mine a little bit earlier. You will have a welcome screen at the top. You can close the welcome screen, and so yours will look a little bit more like this, with a terminal at the bottom. Right, so you can close and bring the terminal to the big window to have a little bit more space. I'll make my screen bigger so it's actually readable on the front screen, but feel free to do the way you want on your thing. The other thing I'll do is bring up the instruction and try to move out the zoom bar. Okay. So that we can kind of see them side by side. Workshop instruction, you can click on a specific command. Yes. Cloud9. Yeah, in the search. So on the AWS console, you can click on the search. And it's called Cloud9. Yes. Everyone was able to open Cloud9 so far? Still working on it? Are you having some kind of issues? Yeah. Those are numbers. Anybody else having issues with the access, even access? Good. No? All right. Anybody still looking for the Cloud9? You're having issues with Cloud9? Everybody, any other person struggling with Cloud9? No? All right. So basically, at this point, this is a workshop. You can kind of work on your own. Small thing. If you click on a command like this, you can actually copy paste this. Control V or Command V, whatever. Mac, Windows, Linux you are. If you want to copy multiple commands, you can actually use the icon on the top right of the box. So if you do this, you should all have an EKS cluster that answers to your kubectl get nodes and have 3 nodes up and running. So, at that point, you're almost ready to move. The lab environment has a command like this, prepare environment and some other section. The goal of that command is to reset your environment to kind of the known state so you're able to do the next part of the lab. So you want to make sure you run, especially the first one, otherwise you'll be missing a bunch of files. So I just ran this. For more information, we're using a sample application in the lab. It's kind of a retail e-commerce website if you want. It has a UI component as well as a couple of dependencies or microservices if you want. The end goal is they will all be running in different namespace inside of your Kubernetes clusters. They use different database backend kind of thing. The goal is I'm sure everybody here already built a container. So, they have different dependencies depending which module you run. You may play with only one of them at a time. There's a couple of chances. So if you're interested, all the Docker files are actually in there. You can go peek, but all of them were pre-built and put into ECR the Amazon public registries, so you don't have to build them yourself. You can just use them as well. So the e-commerce website was built as a microservices, that kind of application. Most components are actually going through a service with a bunch of replicas through a deployment. And some of them are using, well, they use different kind of backend. So the catalog component use a MySQL pods running directly inside of the clusters using a stateful sets. Some of the labs play with this, replace it with RDS kind of thing, but essentially is the overall, the higher level architecture as a UI component as the front end that basically use the other microservices as a backend for the different tasks you're doing, adding, shopping around, whatever. Each of those services are deployed in different namespace. So if you play around the communities, you'll have to play through the different namespace. So, the first task you have tonight is to deploy the catalog microservices in your application. So, the website shows where to find the files and communities, those kind in Cloud9. So first thing first, actually my cluster was probably reset. So I already have the namespace running, but yours should be fresh. So you should only have the 4 starting namespace. We do use labels specifically to watch for stuff created by the EKS workshops. So if you follow the labs, sometimes we use this to filter out only on the specific stuff that we're talking about this in this specific exercise. The interesting thing is now happening with the different files. So if I go on the EKS workshop, on the base application, and on the catalog folders, this is probably what you are familiar with. So if we look, we have, for example, deployment, pretty standard kind of deployment with, specific environment variables, stuff like that. If you look around, it does have a service. It's using a specific service account. There's even a config map that basically tell it how to connect to the database. So at that point, we want to apply all of this. We are using, in the workshop, we're using a template engine. So if you're familiar with kubectl apply-f, you can apply objects directly. If you use the -k, you will actually use the customized templating engine. So there's a way to replace a couple different files, but basically it tells kubectl to look for the file in the folder called customization that is right here, and basically to load all the resources that it is listed in that specific file. So if we run this command, as we can see, mine was actually unchanged, but yours should say created as they are being added to the cluster. I'll pause here. I'm sure some of you are trying this on your own. I thought somebody was sending me a LinkedIn message while I was presenting. All right. Anybody's having issues deploying the first microservices? right? There's a bunch of commands to look for your pods around. I'm sure most people are familiar with this. As we can see, this is exactly the same as interacting with almost any of the Kubernetes cluster out there when you're at EKS, you know, at the kubectl level, right? So there is a command here to scale to 3 replicas. As you can see, this is exactly the same as any other Kubernetes cluster. And if you do the get pod, you'll basically see them. You know, I was too slow. They're already up and running, so there's nothing else to really see here. Anybody having issue with scaling their pods or? All right, so there's a couple commands to poke around the different resources in your clusters. For example, the services. You know, we walk through the basic of Kubernetes. If you never try to troubleshoot something in Kubernetes, one very useful command is the exec command, where basically you can launch a command from you know, basically almost open up a shell inside the actual pod. So for example, here we're using Karl to do a request from inside the actual pod environment, including the variables, everything, right? You know, the best practices tell to use minimal image in your production environment, which probably will not have Karl. But when you're, you know, troubleshooting something, it's maybe a good way of finding the actual problem. So we can see, for example, here we get the JSON output, which, you know, is what we actually expect when we call the catalog. But, you know, you can validate your DNS or, you know, whatever, sorry, network policy you have in place and stuff like that. Is there any question on the first section of that lab? I know a couple of people are still going through it. Looks. So, yes. No. No. So, the question was, is everything running on single instance of EC2? So first thing first, the control plane is running on 5 different instances, right? Which you don't actually see, right? And then you have 3 nodes, 3 EC2 nodes, right? So if we do get pods -oy and looking at all the namespaces, you know, my cluster has a little bit more stuff installed, but since I'm one step further than what you have, let me try to make it into one screen. But you can see the actual nodes where it's running. So it's split across the 3 nodes of the actual clusters, right? And you know, there's when you put deployment, there is something you call the topology spread constraint that can help you make sure your pods are spread across multiple nodes, for example, or multiple AZ as well in AWS. Okay. Perfect. I'm sorry, I lost made my screen bigger. All right. As you know, Kubernetes is a declarative system. So even if you reapply stuff that is already applied, basically the API will tell you there was nothing to change, right? Or it will tell you there's only minimal changes, for example, right? So if I were to apply this in my environment, you know, it will list a bunch of files. The interesting thing is everything was already configured in my thing. For example, outside the one where I did a manual scale option, all the other files were reapplied and basically telling me there was no change. So that's one of the powerful features of Kubernetes. It is a declarative system. You tell him what you want, and Kubernetes will do whatever it takes to bring you to that state, which is quite different than what we used to do before. So at this point, you know, we went through the basic lab of deploying microservices. If you look, you now have the full e-commerce store running inside of your Kubernetes cluster. So I don't know how many people we are, but we have about 60, 80 different e-commerce websites. So if you want to move to the different modules by yourself, feel free to do it. Otherwise, what I suggest is we move to the Carpenter lab, which should take about 20, 25 minutes to run by yourself. So, you know, 2 things we can, you know, the first thing is if we go to the auto scaling with Carpenter, you know, there's the prepare command. Will take a couple of minutes to run. So I'll run it on my environment. And while it's do that, I can go around if people have issues or anything like that. There's a prepare command. And So there's Kubernetes. Yeah. Kubernetes working in place. Yes, you can. We understand the roots, yeah, these business, so we can make this in the yeah, all the so we're constantly internal. Yeah. So you control something that only each place. So you can only do one thing. Yeah. And no, yeah, but but it may come up in an easy word. Also, emotions is not passive, and it's no. So, that's one problem you want to see. We're trying to do this very. Where it creates no claims and bunch of there things. There's looking at what once you start. Yeah. But it's really Anybody else having questions, problems? If you want to throw me tomatoes, just throw them at him instead.
Is it possible to have a mix of spot instances and regular instances when we are?
Yes, yes, definitely. Sure. What happened is 129 came out and we agreed it in workshop and then we tested and it worked, but then the project was seriously came up with they said for 129 it needs to be version X to work right. I don't know why, it was probably something that works, but the workshop was working, but the scaling workshop was still working. So we fixed that, but we probably haven't used the updated version. But thank you. You're the second one that's spotted in 1 month. Third. Oh, you saw it. All right, so probably, most people are probably working on the Carpenter lab, so I'll be running it as well, right? We can see that Carpenter was actually deployed. We're running only one replicas, the even cluster autoscaler, that's the way it works. There's only one really active at a time. So even if we had two replicas, the other one are just standby and, makes troubleshooting and checking the logs a little bit more complex to find the right one. So we decided to drop this down in the labs to only one. So we're adding some what we call IAM identity mapping. So inside of EKS, if you want to access other AWS services, you can use something called an IAM role, which basically will give you temporary credentials. So you don't have to worry about specific username, password, key, rotation, those kind of things. It's all handled for you. You just have to link your service accounts to a specific role that you're doing. So that's exactly what we said, what we did here. So we link the ERN of Carpenter to a specific users in the clusters. So we are able to add and remove nodes from Carpenter. So Carpenter use what we call node pool. And basically a node pool is a set of constraints that you give to Carpenter over what type of instance he can add or to your clusters. So in this case, we are using only the on-demand. If you want, this is actually an array, right? So you can just put a comma, add spot, and it will do both directly in there. You can also have a second node pool, for example, if you want to split your workload a little bit, so you can play with all of this. In the lab, so we are giving it a bunch of large type of instance in the different families, and there's a couple of other settings. So if we just apply that through the customize command, that will create for us the actual node class and the node pool, and we can basically check the log of Carpenter. Some people did spot this specific error. We have fixed this, and interestingly, it does still work. That being said, the service team, the Carpenter service team, did tell us we should be using a more recent version of Carpenter, but should work. All right, so as we see, I don't have any specific nodes right now by Carpenter, so I have a small fake deployment that will not ask any space to run in my cluster. So if I were to apply this, it will start doing it. So if I check my deployment, this is the inflate namespace, is that right? This is the other namespace. Right? Right now we're asking for 0 pods, so it's not doing anything, just the way we expect this to. So if we were to scale this to 5 replicas, and now we can check the log of Carpenter, we kind of can see what will happen. I prefer to see this in a little bit more condensed way. So if we, oops. So if we check the logs, we can already see it did, this line basically saying we're launching a node claim. There's a bunch of information. We're using the on-demand capacity. And basically, right, so we see it did contact the EC2 fleet API, right? So actually, if I pause here, all right, there. So it did do a bunch of things. So there was a couple pods it wants to install. So all the inflate pods that were started, right? And it basically says, I need to create a new node claim. Here's the possible instance type I can use. And basically it's launching the command to AWS. I think I'm missing a line to see the actual results. Did I miss? Oh no, so yeah. Yeah, so the M5 large was launched here. It's using the US East 2A AZ. And basically we also have the instance ID at the beginning of the log line right here. So as we saw, that was actually pretty fast. I'm talking very much. The node is already in the cluster, 93 seconds. And by the time I look, I'm pretty sure all the pods will be already up and running, which was not the case 2 minutes ago. If you're familiar with the way cluster autoscaler kind of works, this is a little bit faster. And also the other interesting capabilities of Carpenter is it can fit the nodes to whatever is trying to start. So in our case, it did start M5 large. And at this point, the labs goes through a bunch of stuff. It will show us it show us the description. So let's do this. So the next thing is if we try to scale this to 12 replicas, right? And we actually wait for this. Actually, I prefer to watch the Kubernetes logs, the Carpenter logs as we do that. We'll see a bunch of new pods come in. I think the GQ make this a little bit slower. Right, so there was so we see there's new nodes coming up. Right, so we have other instances. They're coming up. Right, so at this point, we can actually watch the nodes. So there's a nodes 33 seconds ago that joined my clusters. So it's already happening. And if we watch the pods, by now they're all already in place. If we want to stress Carpenter a little bit, let's go with 50 different replicas. Right, so if I watch the pods doing this with 50, the first thing we should watch is the actual nodes. Should take a couple seconds, but we should see nodes coming in pretty quickly. We take bets on how much time it takes. No bets. Okay. All right, so we have a 1 nodes, 2 nodes, 3 nodes that joins. They're not ready just yet. They have to start a couple component on the node, VPC CNI. They're starting to be ready. So at that point, we can watch the actual pods. As we see, a bunch of them are actually starting up. We're about, 50 seconds-ish. 50, a minute. We did launch about 40 pods right now, with 3 nodes being added to our clusters. And what is also interesting is our nodes were most probably of a bigger size if we check. So there's a couple ways to check this. The first one we can do is check the actual instance logs from Carpenter. As we see, there's a couple of R5 large, since it needs more memory, for example. There's also, if you do the get nodes, you can look the labels on your nodes. There's a bunch of them, but you have, instance families, there's sizes, instance type, there is R5, as we can see here. So if we go back to the actual labs, it will basically look at the nodes just a little bit like we did. Actually use add a column, which is even better than looking at the logs if you always remember that command by memory, which I don't. And let's say we are scaling down at this point. And, at the top, there was a specific section on disruption, which basically says how Carpenter should handle nodes that are not being used anymore, right? So let's scale this down to 5. At that point, it's pretty quick to shut down pods, right? It's already done, but we still have the nodes that are in there. Carpenter has a configuration of about when underutilized, so it will take a couple seconds, and Carpenter will basically delete the nodes. So if we look at the logs of Carpenter, right, you see it's actually deleting the node claim. So to save us money and all this, it will actually remove the nodes that doesn't see any utilization. So that's, you have a lot of control over disruption. The team is also adding more control. So you have, they call disruption budget, to be able to control when you want those automatic disruption to happen, as well as, how many nodes at a time you can actually recycle and reuse and stuff like this. So by the time I did this, we're down to 4 nodes, which is the 3 initial one, which are not managed by Carpenter. So we can mix and match the many node groups, as well as the node managed by Carpenter, on-demand, Spot, Fargate, etc. Yes. Yes.
So how Carpenter will know that?
So in the demo we did, so the question was, how does Carpenter figure out which nodes to remove? Is that what happened? The question? Right. So the way it did it, we scaled down quite aggressively here, right? We went from 50 to 5, right? So there was nodes that were actually empty, right? Or if Carpenter had to move, if he figure out there was pods he could move with the eviction API, it would actually do as well, right? So it can shut down the maximum number of nodes that are not utilized enough. Does that make sense? Yes, Carpenter. So Kubernetes, the scheduler of Kubernetes already kind of does that. It's using the request amount, right, to figure out where to put the actual pods, right? So if the request amount is available in different nodes, you can basically move a pods to a different nodes if you follow like the topology constraint, the spread constraint, right? Those other rules as well. So Carpenter will trigger the eviction API if he can move those pods over to different nodes. Yes. Yeah, so you can configure in the description, we use underutilized here. So we're telling Carpenter it's okay to, if you're able to move stuff. If you don't want to do this, if you don't want to have any disruption, Carpenter has also mode when empty. So we will only reclaim nodes if they are fully empty, right? As long as there's a pod running on it outside of daemon sets, Carpenter will not remove the nodes, right? So you can, you have a lot of controls over what's happening. Sure. Yeah, if you record it in the web Carpenter will do nothing. Well, if you record in the node, you just tell the scheduler not to put any workloads on. The scheduler will not move your pods at that point. It will wait for your next action. Oh, if it's empty, great. If your description is to remove nodes that are empty, there it will pull the node. That's yes. Yes, that's what I think as well. There's a way, you can there's ways to tell not Carpenter to do that. If you just coordinate empty nodes, or you will say, why are you paying for that node? Yes.
What is the nodes decide how many nodes you have? If we say 3 stages.
Yeah.
So the nodes to 6.
Right. So we scale the pods to 50, right? Kubernetes really decouple the application layer from the infrastructure, right? So not sure the pods how much memory CPU they ask. There's a resource, right, of CPU memory. So Carpenter did some basic math, right? Check how much CPU memory needed, did some compute and figure out like any instance of this, and that remaining. So maybe the first one were the large or X large one, and then the other one is, I need only a large tree.
So from the schedule or size is like how many nodes you have?
Yes. Yeah. So the scheduler is kind of the next step, right? To assign them. Sure. Well, there's a question on it.
Yeah. Is it possible to pre-provision two extra nodes? Let's say I don't want to wait, but I want to have 2 worker nodes, always extra for the branch.
So Carpenter does not have that feature built in. That being said, even if there's way to do that with priority and preemption first, right? You can have small pods. They could be running the pods image, right, which are not doing anything, and they reserve some type of CPU or memory capacity. But you put them at the lower, the priority and kind of reverse, right? And so if you have, so they will keep, Carpenter at that point will keep nodes to run those pods containers, right? And if something more important comes in, basically the preemption will remove those pods, right? That's Carpenter fully support that if you're looking.
So if there's no edit pod on the nodes, Carpenter will deprovision these nodes.
So if you configure the description, right? If you don't put anything for description, Carpenter will leave them. But most people set some kind of description policy.
I have two questions.
Sure.
First one is there a delay to pull the node up? You could say like 5 minutes after there's no workloads, then you can. remove it,
Yes,
sort of thing.
you know, anywhere from 1 second to a year.
Okay, cool.
I'm
And then
not sure the limit.
is it fair to say that Carpenter is only as strong as your resource limits and requests? Because when it is scaling up, if you have ridiculous resource limits and requests, it will scale up appropriately.
Yes, but I mean, that's also right from the scheduler point of view. The scheduler will use your request to decide where to put pod. So if the scheduler is taking a run decision, the carpenter will not even see a pod pending. So, yes, but it's by design.
Yeah, just from an ops standpoint,
Yes.
kind of harass developers to get their requests and limits.
Yes.
set it properly.
I mean, if this is wrong, the scheduler will put them all into one node, no matter what you do. Right, unless you have a shred constraint and stuff like that, which Carpenter will also understand and follow, right? So if you're saying I want 5 pods spread across 5 different hosts. You know, even if there's capacity, Carpenter will see that and will bring up extra nodes to fit that workload. Now, it may be smaller because your request is too low, kind of thing, but you know, it will fold.
Yes.
No problem. Yes.
So if there are any humans is running, for example, Dynatrace managing is running on those nodes, in that case, what do Carpenter do? Will scale them down?
Yes, just like cluster level scalar daemon sets are not taken into account as real workloads. So they are, you know, when a node only has a daemon set, they are considered not running real workloads. In most communities, thing I know, that's how it works. I think we're going to question mode, so, you know, feel free, if you have other questions, you know, we're kind of done with the actual labs. You know, feel free, there's a specific workshop on Carpenter, if you want to do this. Otherwise, we did talk about the quick survey. So, you know, if you can snap a picture of this, I'm happy to take any other question from now on. I'll be sticking around. I just got a notification that my plane is delayed anyway, so I'm not going anywhere by the look of it. Yes.
Use
Yeah. Yes. So it always depends on how you use Kida, I guess, but you know, Kida will scale your application level, right? The number of replicas of pod that you run, or deployment from 0 to 1, those kind of things. So Carpenter will just adjust the number of nodes underlying those applications that you want to run. So there's no obvious problem. The only thing, so Carpenter currently needs to run to be able to add nodes, right? So you need to have a place, you know, if your goal with Kida is to remove all the nodes and have a cluster with no nodes, Carpenter has no place to run at that point. We're gonna have it. That's the only process.
Thanks, Matt.
No problem.
Please fill the feedback form. Also, I have a bit enough time. I know we announced already the new panel thing. If you don't copy the code, you wanna reach out, then you read the code, let us know. One of us. Or you can see the coding also, I think we will post it after. So we have a quiz based on this presentation. We have been 3 to 4 cloud memberships, one by one. So we're gonna have which for this. Yeah.
No problem.
This one is on this big tools getting up GPUs and this top end, the pods requires a GPU.
Yes.
Like different specifications.
You can do.
You can do that accordingly. Now we do CPU. Even we have our own space.
So yeah, after this engaging workshop,
That's a good question.
we have a small quiz. I won't take much of your time, 5-10 minutes maximum. So I'll quickly sum the rules in front of you. There's a QR code on our screen. You need to log in on Confab. You need to enter your name. There will be 5-6 questions. Each question will have 4 multiple choice options, mostly content from whatever we discussed today from the workshop. And each question would have 25 seconds for you to answer. So the fastest ones would be on top of the leaderboard. And we have some giveaways for top 3 winners. So make sure you are the fastest and you select the right answer. I'll wait for a couple of minutes for everyone to join and I'll start. You might not see the questions on your phone upfront, but the screen is already shared and I'll also dictate all the questions for your convenience.
So that no one is single answer, that's multiple choice, right?
Yeah, only one question. So you will select one option from 4. One will be correct, others obviously won't be correct. And if you can't scan the QR code, there is a URL as well. So you can join it from there as well. No, you can play that as a guest as well, but make sure you type your name correctly and you remember. Otherwise, if you are on the leaderboard, we won't be able to issue the giveaways. Okay, let's go. The first question. What are the elements in Kubernetes clusters that contribute to the cost? Kubernetes stacks, worker nodes, YAML files, or kubectl command line utility? Okay, 93% people got it correct.
I think we need to select this. Now it will show up. Now we will select.
For how many months does Amazon EKS support a minor release version before changing to the extended support? 6 months, 12 months, 14 months, 14 years. The correct answer is 14 months. Third one, Amazon EKS supports running Windows containers. Yes or no? This is so easy. I wish I could play this quiz. I wanted all the giveaway. Fourth one, what's the name of the service that lets you run containers in serverless manner on Amazon EKS? Argo CD, serverless containers are not available on AWS yet. NeoGate or Fargate? There is someone who selected NeoGate. Really good. Kudos to you, man. The fifth one. What is the name of open source cluster autoscaler project released by AWS? Bricklayer, Carpenter, Help, Carpenter.
Please select some wrong options as well sometime. Okay, probably this is the last one for the day. What is CNI in Kubernetes cluster? Crazy network interface, container network interface, confused node integration, or container networking injection. Okay. That brings us to the end of the quiz and today's workshop as well. I would like to congratulate and invite all the top three members who won today's quiz, and I would request them to wait a little while after the event and give us your information so that we can issue your giveaways. And yeah, let's adjourn. Thanks a lot, everyone, for joining. Again, that's time from us, and hope you enjoyed today. Thank you.